Hello, allow me to continue where I left off. I took a small break and went and collected this converter. The thing what you see on this converter is it has at the back an area which is exposed. Seen this, no? And then this is slightly expensive one. So we have what you call these capacitors which are mounted almost flush. Seen this, no? There are nothing, there are no projections here. This is slightly different from the converter, what you call the the buck converter which I have shown you last time, where these two capacitors were lead in hole type. Here in this case is absolutely flush. Now if I were to take something like this and try to make a box which I am showing here, life will be somewhat easy for me. Seen this. So I will just select all the only 3-dimensional objects. Anyway, in our case now it is called polysurfaces, and then I will hide all the non polysurface objects. Now I will hide everything. See here, this is the basic unit which I have got here, and this is where I was trying to tell you yesterday. Imagine these were made with aluminum, and I will also use the same holes which are used for fixing the printed circuit board directly to the base. So we have three objects here. We have the box, okay, one part of the this is the cover, there is the heat sink, that is the enclosure. Looks nice. Now if you remember last time when I left, I told you that I will not play around too much with the small boss, okay, small boss that is projecting, and then that how that box is coming, that boss is coming and what do you call, interfering with the capacitors here little close. That is because the actual capacitors for the printed circuit board we have are little smaller. These are little smaller than that one, no, sits nicely here. So we have the basic things all worked out here. This is what I just wanted to say, except that if you are part of this solid modeling thing, difference is in the case you want to visualize the product, it will be nice if you have a small radii in the corner. So just to make it a little more what I call presentable, I will now go out, select all these, select the cover, select this, or let me start with this unit itself. I will go here, to make it, when we try to attempt to render it, see how it looks. Right now it looks a little harsh because the corner what do you call, highlights are not caught. It looks flat and not that much presentable. It looks a lot more like a 3D object and not a real object. To make it look like a real object, it is very easy. All we have to do is go to this what do you call, solid command, and then we what do you call, fillet the edges, okay. I make a very tiny fillet, a little what do you call, I will say small minor problem is there, kindly put up with it. But one thing you will notice it, this object, no, looks, see the corners have all been rounded, and same thing has happened to the corners here. But this is what you call a bug because of various other things. So right now I will undo it because my interest is not about this how to fillet it. My interest is more about how to make real life objects. In the case of this rapid prototyping and especially 3D printing, very difficult to create fillets. Fillets create a nuisance because that circular portion does not print well, which is different from any other construction and especially different from sheet metal or any what you call wherever some shear is applied or wherever bending is applied and so on. In a way it is very convenient for us, except that when you want to actually make parts like this, can you see what it is? This is a small capacitor, probably it is a, I do not know, it is a, oh I will see what they have written here, probably it is a paper capacitor which is 440 volts, 1.5 microfarad something and something here, can you see it? For items like this, to make the corner sharp and so on is very difficult in injection molding, because you cannot make a cavity which is automatically has sharp corners, especially this one of these corners, whether you like it or not, it ends up with a built-in radius. In the case of 3D printing, it is very convenient and easy for us. The slightest problem, without the slightest problem we can print such a small thing. This is, now I will just take a small diversion. Now if you see here, this part can be one of those parts. So to make it a little more what do you say, interesting, I will try to give it a, give some attach some materials and then try to see what best can be done. I have given a random some blue color to this to identify it with the other things, and then I will give another color for this, maybe a green color for that, okay, and then I give yet some other color for this, just to distinguish these things when they finally get printed. I am sorry, when you observe them on the screen here. See, all the 4 parts have got different colors now. It's easy for me just now, because I wanted to be fast and so on. I have chosen green, which is the normal color of the what you call photoresist which we have here. In this case it is purple. Then I have also chosen something else for this. I could have left it grey color, which is typically a sheet metal part. And then I see here I have 2 mounting holes which are actually matching this printed circuit board mounting hole, and on the other side I have a cover which can I can now make this cover as part of this. Then from the top I introduce the printed circuit board, and then we are nicely into a useful product. So slowly my intended 3D printed object is getting ready. So it is a question of, I will one more time now, I will just see whether I can join these 2 things. I will keep only those what you call visible, and then try to see what best I can do. depending on the various features. I will see whether it is possible for me to Boolean them and make it into a single solid. So, I will try to union them. It has failed, do not worry too much about it. That is because some of the things may be open or something like that, they may not be joined together, some issue may be there. Finally, printing an object like this is not difficult. Okay. So, now again if I give a render, you see I have a cover which is there on all around, and then we have a small depression such that this tuning can be done here. We have made something across such that tuning can be done here. In this case it has been made such that the top surface is flat. This is the original. In this case you see top surface is almost flat, and if I have a thickness, if I give a countersunk, nicely that small screw projects out of it. So, in this case we do not need the that what you call that small thing we have given. Overall I will have a small box for it. I will show you the soldered one. In this case we have 4 wires coming out. So, you need to do something about the wires. What are the wires which we can do and so on. Now, this is where our next level of advantage of a 3D printing takes place. Saying conventionally what we would have done, we would have tried to take 2 wires here to try to do some wires and so on. Looking at this, we notice there is a lot of extra space here. It is very easy for us to build probably an input and probably an output. If you want this to run from a, let us say this is supposed to go and drive a modem or a mobile phone. Suppose I need to make a 12 volts to 5 volts mobile phone charger. I have 2 options. One of them is I can have the wire here which directly can plug in here. Alternatively, I can have a USB type plug here, and if I have a OTG cable, on the go cable, so it will be possible for me to just plug it in here. Seen that, no? So, now I have a chance for me to, if I can see whether I can build a cable with a with an OTG, I mean counterpart of the OTG cable. Here I have it, and this other end I can decide what to do. I can leave 2 wires, or I can maybe give a crocodile clip, or I can make it saying it should be part of some other place where I have other voltages available. So, this is where the core is same, where you need to produce things outside can be very what you call effectively handled using our this thing. Now, I will try to, at the minute I will try to what you call close it and come back to a more interesting thing. If you remember last time I left this, I said, rather I promised I will get back to you with a better thing. This is part of a oscillating fan. Now, you see here we have a fan which this is rated as some 75 watts. So, you can convert it as to how many how many watts make the horsepower, and based on the how many watts, loosely I will take 750 watts make 1 horsepower. So, 75 watts is 1/10 horsepower. Given a 1/10 horsepower and given all this mass and all that, I can calculate how much of force is required for it to turn and how much is the reduction that is turned. And in this case you notice from manufacturing the shaft itself comes with a worm at the end of it. Over I do not know, maybe almost a century, it has become standard to have the worm built into it. This back portion has changed a lot. Long ago they were all made in brass, because brass was the easiest thing that was available for watchmakers. Now, whole thing can be conveniently printed on a this thing made out of any plastic, typically a simple injection molded plastic. Now, if you remember last time I showed you that one epicyclic gear train, saying if you attach it, we can attach it to the ceiling. Instead, in this case, I have a different type of a mechanism. In this case, this is where I thought, no, I will show you how these things can be put to use. You see here, if I open it here, I have several gears, and this one of these gears, this directly mates with this. See here, this gear mates with this. Good. Now you see here already there is a reduction. Generally this reduction may be of the order of 1:10 and so on, depending on the pitch. While the speed is reduced, in our case a little desired effect is the torque is improved. Torque is increased tremendously because a big fan has to rotate. Then the second resultant thing for that is speed is reduced, torque is increased, hence these parts become very critical. Designing these parts becomes very critical. So, one increase in torque, reduction in speed, next level next increase in torque and the speed has happened here. Now you see here, we slowly end up with more and more items which depend a lot on friction and mechanical forces. So, wherever such things are there, we have no choice but to continue to use metallic objects, load bearing. Possibly, if we had thought very carefully, it may have been possible for us to replace it, but over the years they would have found out, no, probably this is already a standard item and they have it in large numbers, or friction, and secondly the tangential force in this, there will always be a little bit of force between these two. This will lead to a problem. So, they have decided to keep things as they are. So, in this case, this is an ideal candidate for being manufactured in 3D printing. So, I just allow me to show you the same pictures on the screen here, which I have here. You see here typically, see this is the mechanism which I was trying to show you. So, these are reasonably good candidates for us to make, take the next level of this thing to this. So, right now due to some this thing, I will try one more time, I will see whether, anyway it is nothing, it just shows all these parts. Yourself can maybe go to the go to this websites and check for detailing like this. You see here at the bottom, the small detailing which can be done here. Same thing, much more explanatory. I had to go and break a motor to get you this. So, I think now you know a little about how to, which are the parts that we need to deal with it. Now, getting back again to this motor, please have a look at this motor. You see here, when I want to assemble it to this, when I need to assemble this mechanism to it, one of the first thing is it should have perfect alignment, and randomly with a high speed when I try to push it, automatically alignment should take place. So, there are 3 fixing screws, metallic again, and then these are all bosses here which will go and sit here like this. These are very convenient to do. And if you have the file with us, irrespective of the stack, irrespective of this diameter, irrespective of this is required for a big fan or a small fan, we can always modify it, and then if you want it in a few hundred or even 1,000 numbers, printing a part like this makes a lot more sense. And right now materials are available which will help us in printing these things without any difficulty. Here, because of various restrictions, they only one hard type of I think probably it is a nylon and it is injection molded, and because of this you have radiuses here and everywhere there is a taper, and anything you want to do here everything has something or the other which is part of some other thing. So, we have this, and here you come into the next level of choosing fasteners. This one is a coarse pitch self tapping screw for this plastic thing, plastic items, because you are not expected to frequently open it and play around with it. So, we have this. Okay. So, again getting back to this design point of view, no, you should pick on objects which are printable. Now, if you see the other side, one more small detail I wanted to show you. You see here they have given a small step here and left the remaining material. It is because in the case of injection molding, it is very important that overall no total weight should be less, and how the flow of material takes place is very critical here, hence all the drafts and all. In our case, if you see the other this thing, it may or may not be required like this. In fact, you can have probably a block and then have something long here and it will do equally well. So, either you save in this material or you save in the support material, or alternatively how you place it on the table and then which way the orientation takes place. Later on another place, no, I will try to show you that thing. So, right now I will stop here and take you to a very small interesting thing. Now this is also an interesting thing here. Earlier when these were all made with metal, a separate clamping device had to be made. Right now not needed. Either you modify this part to take the clamp, alternatively you modify the capacitor, and itself by itself, no, it comes with this beautiful thing, and then happily we have a nicely built thing. And these days it is also possible that there are what I call machines where you can stop the process in between and add metallic inserts. Right now we do not have the facility. So, for the next maybe 10 minutes I will show you, I will take a small diversion and I will show you something else from the what I call interesting thing. This is all about how they make cars. This is taken from their Mazda's website, and one car enthusiast shared it with us. I would like to acknowledge, saying the starting point of any big thing also is sketching and 3D design. I will go through it very quickly, maybe if you are interested, no, you can watch again. So, obviously starting point is where somebody sits very carefully and worries about the product. Can you see here? These are concept sketches, and there is something else here. I am not at all sure what it is, but there is a theme that is copied here. There is a theme. This may be related to the gear shift lever, or it may be related to the external mirror, or it may be anything, but what is trying to explain is that there is a theme about it, and in this case in fact it is a small thing saying it is a CD screen. You see here at the bottom here, you can see that it could be part of the speedometer, or it could be part of entertainment system or anything. These small details can easily be printed in 3D. Earlier it was not possible, somebody had to do this. Is about I think 20 years old presentation from them. You see here how to open a door, and somebody is showing all the various details, hand details, and somebody is working about all these things. Advantage is there is, if you were to make a proper model like this, probably a scale printing can be done. So, you have 1:8, 1:16 scale model things are available. It is possible for us to make a scale model print so that we can show others, saying how the whole object is going to take place. Designer, and these are the people who work on the interiors. So, you see here at the base all the various type of materials which are required for the upholstery, interiors, everything are there, and all of these things can now happily be printed on a scale model. This is slightly different. They are trying to make a working demonstrable model so that it can be shown at an air show. So, they have taken a previous platform and then trying their best to attach all these two things, and then you see here they have tried to make a door, and then inside the whole thing is filled with polyurethane rigid foam structures inside, and then later on they will cut it, and you see here we have something else here on the top here. I am not very sure what it is. It could be a digital sculpting device, or it could be a what do you call coordinate checking machine and so on. So, with this it is very much possible for us to get the desired shape and whatever we want to do. These are all thick urethane foam here. You see here urethane foam here, and can you see what is going on in the back there? Somebody has taken all these parts and they have made a seat, and the seat is being covered with some what do you call vinyl, so that it looks natural, and they are trying to probably build. I am not sure that the front or back of the object. Slowly it is getting up. So, obviously this is the front, this part of it is bonnet. You see here something is already sitting on this. So, I am not sure whether it is actually a fiberglass device or it is a what you call sheet metal or anything, but what is really is it is a mock-up and almost near working mock-up. Next picture will show you. You see here, you see in the front we have the concept, and at the back you can see that already slowly the concept is getting shape in 1:1 full size. Now people tell me, and then occasionally I have seen on the internet, full-fledged printing can be done on large objects also. See, all the people are happily sitting here. So, what you have seen there is probably a fiberglass mold. You see here, this is the fiberglass mold at the back. This is one side, that is the other side, and then the whole thing has been built out of it. So, this is the design team, and God is in the details. See this, it is getting ready. Life is so easy, is it not? And so interesting also. And somebody is working on the finishing of it, saying how do you paint it, where will the gaps occur, and then where do you catch the highlights, and how do you make it look as authentic as possible. And this is the paint shop. So, after gluing and doing everything, you see here something else has been done here to make the bonnet look real. They are building upon that. This is a little difficult. I am not able to at the minute tell whether it is only a mock-up or it is actually a implemented piece, but that you see here, each one of these elements can easily be simulated, including all the, see here, this is the, what you see here in the inside is the instrument cluster, and in the instrument cluster they have very important things. Outside you have something, and these numbers look threatening. There is 150 kilometers per hour or 200 and so on, and there is a beautiful steering wheel also, and at the back this is the LCD screen which was there in the earlier picture. People are sitting there, and this is real. You have seen this, no? This is a real this thing, and it is a very peculiarly integrated headrest. If you remember that LED screen, no, this LED screen is for the passenger here. Now it becomes a little tricky. I am not able to make out it is just a rendering or it is a what do you call actual model. I think you will be very easily, you will, because of the strong contrast and the way these what do you call shadows make out, it is obviously a rendering. And the next picture will show you because it is being a 3D, the moment you make a 3D model, lighting and adjusting things are relatively easy. What just gives away our thing is probably last minute, no, they had to make this, and it does not look very, very authentic. Better same 3D rendering. Now we come to a little thing. Is this real or is it virtual? The magic is, it looks like it is a mock-up which is real. It is not a virtual model, it is a real model. So it can be lugged around, and they have taken this and also presented it at the show. So, there is a grand entry on the stage when it is presented at the what you call auto shows. But to get at this, why I have shown you is saying modeling is very very critical, and the more detail you built up, no, the better things are. So, I will stop here, we will meet again in the next this thing. And why I showed you this is, it is now possible to print even those large things in 3D printing. So, thank you, and this is actually a real mock-up. Probably it is stored and kept there, it may not be moving, but it is kept there, and this is what is got ready at the what do you call on their premises. The only small thing is the way the wheels are rotating, most likely the wheel rotation is done in probably Photoshop. So, I will stop here, thank you, we will meet again, thank you.